Good morning, everyone. Welcome. Thank you for coming. I'm excited to be here. It's amazing to, this is ludicrous. We've all come so far. I'm the co-founder and CTO of Apollo. If you're not familiar with us, our mission is to advance GraphQL and bring it to every developer on the planet. We think it's a transformative, generational technology that brings extraordinary benefits to app developers and to teams and companies that care deeply about their users and the experience they have. And my message today is simple. As Peggy said, GraphQL is mature and GraphQL is approachable. Companies are adopting it rapidly, I might add, and not just on the margins, but in their most valuable products and business-critical applications. They're making a big bet on the technology, to be sure, but also on a broader graph strategy. And thanks to this momentum, the GraphQL community has made great progress, I think, on many of the most important questions we faced over the last year. It's really been a fantastic year for the movement. And so what I wanted to do today is share, at an architectural level, what's become clear over the last year that has me so excited about GraphQL and leaves me feeling so confident about its future. So I prepared to talk about a few major architectural advances, and in practical terms, why they're important and what they mean for teams at each stage of GraphQL adoption. So I hope you like boxes and arrows. Let me start with the core idea of the data graph. To explain this and to understand the rise of GraphQL itself, let's look at app development today. Pretty much every company feels the pressure to build great user experience. It comes from users and customers, right, who expect modern, immersive, data-rich features. A modern e-commerce experience, for example, can't just be a list of products on the screen anymore. It also needs recommendations, reviews, personalization, thoughtful cross-selling, real-time inventory and pricing, and so on. These are just the table stakes to have the kind of experience and the kind of application that people now expect. And more than that, users want to use these apps on a dizzying array of platforms. So it's not just web and mobile anymore. IoT, the watch, voice, CarPlay, something coming next month, and all with a seamless overall experience across each of them. And so the big challenge, what's really hardest about app dev, is wiring all that data to all those screens. The days of a big database or a simple backend powering one front end are long gone. And so to solve this, you end up writing a lot of code, right? And whether it's state management and data fetching code in your clients, or whether it's feature APIs that are tuned for a particular screen that live inside your services, or maybe it's a backend for front end that assembles data from multiple backends and transforms it into something more suitable for a particular client. Whatever it is you're doing, you're writing a ton of special purpose, feature-specific code. And worse yet, it's one of those M by N problems. You know what I mean? Every app and every service just digs you deeper and deeper into the hole. That data code is the slow and frustrating part of app dev. It's what limits the kind of user experiences teams are realistically able to ship in a world of deadlines and constraints. And frankly, it's just an unwelcome detour. We signed up to make great user experience, not to do this stuff. So the way out is the data graph. It's a new layer of the stack that decouples apps from data. And it gets you out of the business of building all that brittle plumbing. And GraphQL, of course, is the language of that graph. Services describe their capabilities as GraphQL schema. Applications describe what they need, their requirements, as GraphQL queries. And the graph is a rendezvous point, or a marketplace, that connects the two together. And this architecture is what's driving GraphQL's extraordinary growth. When most people talk about adopting GraphQL, this is the thing they mean, a data graph. It's the architecture that best allows teams with existing data and existing apps to get on the GraphQL train and enjoy its benefits. And that's exactly what so many teams are doing. Companies of every size in every kind of market are putting a data graph into their stack and putting their most important applications on that graph. PayPal, for example, has made a huge commitment to the graph. They have over 50 products now relying on a data graph, replacing tightly coupled, handwritten backend for front ends with GraphQL schemas and queries, taking advantage of GraphQL's great tooling to ship faster and improve the developer experience. NerdWallet just rolled out their first graph to support their shopping and rewards platform. The graph replaced one-off APIs and SDKs, and it allowed their teams to collaborate on cross-product features that were difficult to build with their previous siloed architecture. So what is it about the data graph that makes it suitable? Why this particular approach? And what's allowed it to grow so quickly? Well, for one, it's really good. It's just a better way to do APIs. First, it puts all your data in one place with always up-to-date documentation, and it gives every developer a single, consistent way to discover and access that data. Two, it decouples your apps from your services, allowing each to evolve in their own best way without any costly entanglements or having to navigate conflicting priorities. And three, it lets us build great experience faster, not just with less code, but like PayPal and many others are finding, because of great tools that enable teams to be more productive than ever. But it's not good enough to be good. For a technology to spread quickly, it also has to be approachable. And that's the really big benefit of this architecture. It encourages an incremental approach that lets a single team get immediate benefits while laying the foundation for something that will grow over time. So in particular, a product engineering team can build a simple graph all on their own, as many of you have, enough to support a first product feature, and get that graph all the way into production in just a sprint or two. You don't need any changes to the back end or help from the team that owns it. And you don't need to convert your whole app at once. It's better, really, just to start with one screen or one component. Adding more data to that foundation is easy. You can talk to anything. REST, of course, Thrift, gRPC, SOAP, XML-RPC, whatever you've got, with zero change. We're working with teams that are integrating mainframe data into their GraphQL. And they do it because the data graph lets them build extraordinary experiences on top of something that was too cumbersome before. And each thing you connect into the graph adds more and more value. As you do that, it's very natural to add more applications. The adjacent native mobile app, perhaps, to the first desktop app that you built. And as you add the third, the fourth, the fifth application, the value of the graph grows and grows. And often you can simply replace entire backends for front ends with just queries, because the data is already there. There's a virtuous cycle here, a literal network effect to the graph. And what I think is especially interesting is that the graph is really a product in its own right. It's not just a better query language or some technical change to how data moves around the network. It's a fundamental and essential building block for the modern stack, centered around a schema, the catalog of all your data, and the tools and techniques we use to manage and access that data. That schema is what makes the data graph different from REST and other API technologies. More than being about the details of how to fetch it, it's really about the data itself and making that data more useful, accessible, meaningful, and valuable. And so I encourage you to think about the graph this way, as a product, even at the earliest stages when it's the first few engineers building that first schema. So the data graph architecture is valuable and approachable. It's also mature. About a year ago, we wrote a set of 10 principles that document the essential concepts and methodology behind building a proper graph. They're not my ideas. They reflect what I've seen works best at hundreds of companies who've built out a data graph. And since we first wrote these, we've become more and more confident that they'll serve as a helpful guide and roadmap for teams building out a graph themselves. They cover three main areas: a set of principles that define the overall shape and structure of the graph, a set of principles that lay out an agile development process for the graph, and a set of principles that cover how to operate the graph and integrate it with the rest of your production environment. I urge you to read these and share with your team. They'll help you get the most out of your investment in the graph and from the tools and systems that support it. These principles also frame some important differences between GraphQL APIs and traditional APIs. For example, often we're used to thinking about APIs as being the perfect, normal representation of our data. We spend a long time on them, in large part because they're really hard to change once they're in the field. But the data graph isn't like that. Instead, we've found over and again that it's better to adopt a demand-oriented schema that's designed for how clients want the data. And instead of a waterfall approach to design, what works far better is an iterative approach. The teams getting the most from their graph approach it like product development. They ship early and often, thinking in terms of a continuous loop from design to build to ship to learning and back to design. And rather than focusing on getting the graph exactly right the first time, which doesn't work that well, what you actually want is to optimize and accelerate that cycle time until you're able to iterate on the graph at the same speed that you iterate on products. And the graph, complete with the right tooling, lets us do exactly that. Let me show you an example of how this works with Apollo. Apollo is more than just a GraphQL server. It also includes components like a central schema registry that acts as a source of truth for what's in the graph, and a system for capturing metrics about how the graph is used. These are a co-equal part of the graph alongside that server. And one thing they let us do is schema change validation. The idea is really simple. From CI, we can take a proposed update to the graph. The registry lets us compute a diff against some previous version of the schema. And then we validate each of those changes against the actual known production traffic against the graph. And because GraphQL is statically typed and because clients express their specific data requirements in the form of queries, we can do that algebra statically at build time. And so the upshot is we can validate changes even against applications for which we don't readily have access to their code, like older versions of a mobile app or an ad hoc script written by the marketing team that queries your graph. And you will, by the way, have ad hoc scripts written by the marketing team. And we don't just get a list of queries or fields that don't work. We get an actual manifest of registered clients adversely affected by the change. Without a ton of work, this kind of thing isn't really possible with legacy APIs. When something hits a REST endpoint, you really have no way to know how that data is being used or what the intent was. And what makes it possible to do this with the data graph are these components. It's a critical point. The graph is more than just some resolvers. It's a catalog of what data is available, what clients are using the graph, structured logs of how they consume it, a historical record of how it changes over time, and a set of workflows that are built on these, like schema change validation and others that you'll see during the conference. We call this stuff the Graph Manager, and you'll need one. Whether you use one built in with Apollo or build something like this yourself, these tools and workflows are an essential element of the graph and where a lot of its biggest value lies. OK, so we have a clear architecture and the tools to support it. The last, most important thing is the talent. Products have owners, right? Someone has to own this thing. So there's a new role, a really interesting job, I think, that we keep seeing come up in companies that are adopting the graph. It's the Data Graph Champion. It's the people that take responsibility for the graph as a product and come to work to make it a success. Early on, this may be too silly a distinction, right? It's the team that wrote the server. But remember, I said earlier, it's helpful to think of the graph as a product. And so even at the start, we can talk about some of the responsibilities that start to emerge and define this role. First one's pretty straightforward. It's the team that deals with the infrastructure, your tools, your gateways, editor integrations, and so on. It's worth carving out the time to do this, especially as the graph grows, because many of the people working with the graph won't be as familiar with GraphQL tools and how valuable they are. The second, more interesting one, I think, is responsibility for the overall health of the graph. Part of this is establishing conventions, patterns, styles, and so on, ensuring that the whole graph feels consistent across all its parts. Design, like a product would be designed. And a really interesting part of this is metrics. I've noticed a lot of teams starting to think carefully about what to measure and how to set goals for their data graph. You might start with performance, availability metrics, but you can go much further. At Apollo, we're starting to borrow ideas from product teams and give our graph owners adoption and growth metrics. It's interesting because the graph captures intent. You can do some really interesting things here, going beyond technical measures to track the real value of what you've built into the graph. And finally, and I think this is really cool, the Graph Champion ends up spending a lot of time helping other teams be successful. The data graph team at Expedia is a great example of this. Expedia has jumped 100% into the graph. If you book travel, hotel flights on Expedia, you're using an Expedia-wide data graph that dozens of engineering organizations are contributing to. And what's happened is that the team that initially implemented the graph now finds that they spend much of their time helping others. And they found there's a whole art and discipline to this task. One thing they've learned, for example, is that instead of being gatekeepers for the perfect schema, it's better to help teams get on the graph quickly and then give them the tools they need to iterate their way to a better design. To teach a man to fish sort of thing. And so you can see how all this ties together. You make sure the tools are in place to support an agile, iterative process, be clear about what good looks like, and then help guide teams to get there, empowering them to be graph developers themselves without getting too much in the way and letting the graph grow and spread across the organization. Does this sound familiar? How many people here are doing some part of this today? How many want to do more of this? Yeah, I think it's a cool job. Awesome. So before moving on, let me reiterate the key point here. The growth of GraphQL is tied to the need for a data graph. I want to be really explicit about this. And it's an approachable and mature architecture that will serve you and your teams well. I talked earlier about the network effect of the graph and how over time it can and will expand. And so this brings me to the second major development, how to effectively manage an expanding graph, particularly as it grows into a shared resource that multiple teams use and depend on. Here's the issue. For most teams, at some point, a monolith doesn't make sense, whether for collaboration, modularity, fault isolation, or to accommodate diverse technical stacks, or scaling. Whatever it is, teams want a story for how to implement a graph in separable parts. It's by far the most frequent question that I've heard from Apollo developers who are delighted with the graph, but aren't sure if or how to scale it up. What we want is fairly clear, a federated architecture that allows multiple teams to build a single graph from separate parts. But the reality is that's hard. In the past, stitching multiple schemas together like this required a lot of code. And it's not the kind of code you want to be writing. It's code that joins pieces of data in really intricate and hard to debug ways. There's operational issues, like how do you coordinate the gateway and the underlying services so that they move forward in sync? It's difficult to understand the behavior of a handwritten system like this at runtime. And you don't get a lot of the benefits of GraphQL, like strong end-to-end typing, static analysis during development, and so forth. So working closely with many teams that went down this path, this summer we released Apollo Federation, a specification for how to compose multiple graphs together into one. And it addresses the three concerns we heard over and again from teams. Number one, it gets you proper separation of concerns. Federation allows you to build the graph in completely isolated pieces, each responsible for one part of the graph without complex entanglements between them. Two, it's a declarative architecture. You don't have to write code. And three, it's just GraphQL. It's standard compliant. You don't have to rewrite your apps. It doesn't break your tools. And this isn't just for really large companies. Federation is really a model for team collaboration at every scale. Notel, an office and property management company out of New York City, runs a federated graph. It brings together every team, each with its own product deliverables and roadmap, covering everything from core building data to ticketing and support to their supply chain management to their sales team. Each team owns its piece and ships its products, but all brought together into a single graph that makes it easy to navigate all of Knotel's data as one. At a technical level, Federation is just a way to compose schemas and query across them. Let's look at an example schema with products and reviews. What Federation lets us do is implement that schema in pieces like this. One team handling products, the other team handling reviews. But the better way to look at it is this. Federation lets two teams working completely independently collaborate on a single shared graph. And all the big ideas of Federation are on this screen. We have proper separation of concerns. The review and product services written in completely different technologies can reference and extend each other without making the relevant code scattered across more than one place. It's declarative. There's no code to stitch these schemas together. Federation instead uses keys and strong typing to allow static validation of how the schema is composed together. And it's just GraphQL. These services on the left are standalone. You can develop, test, and run each of them in isolation. And also, the graph you get, that's GraphQL too. It looks right, like a person designed it. It doesn't expose the service boundaries to the clients. And the clients and the tools can work with it unmodified. And here again, it's the tools and the workflows that really make this stuff come alive. In Apollo's implementation of Federation, the Graph Manager tracks schemas for each service that makes up the graph. So when you deploy a new version of a service, you also push that definition to the Graph Manager. It runs the composition algorithm, computes a new schema, and pushes that to the running gateway, potentially after a review or approval step. And then the gateway exposes that new graph and smoothly transitions over to it without any interruption to your clients. So there's no need to change or restart or even give teams access to the gateway. It's just shared infrastructure. At runtime, the gateway executes incoming queries by splitting them across underlying services. And to do that, it first constructs a query plan. Every query has one. It's the recipe that the gateway is going to use to fetch from the underlying services. What order, in parallel or serial, which keys is it going to use, how does it do joins, and so on. And akin to a database, the query plan is something you can look at. So it gets logged, and you can use it to diagnose how the graph works and understand problems and performance issues in production. Schema change validation works too, and now it's kind of the holy grail. One team can validate a change that they want to make to just their service. The Graph Manager takes that proposed change, composes it with the balance of the graph, generates a diff, validates each piece of that diff against the known production traffic, and what we end up with is a list of clients that would be affected adversely by the proposed change. It lets each team go at their own pace to support their own work with the safety belt of knowing that every use of their data is safely confirmed against each change. Like GraphQL itself, Federation's a spec. It's a set of conventions that anything can implement. And just a few months after we published it, what's really exciting to me is the community momentum behind Federation. A ton of servers, including popular projects like GraphQL Java and GraphQL Ruby, now support this. So you can mix and match these into a single graph, as we do ourselves at Apollo, combining Kotlin and TypeScript services into one graph for our own API. And it's not just languages. GraphQL native databases, too, have added support. And I'm excited to share that both the dgraph and fauna databases now implement the Federation specification and can be plugged directly into a data graph alongside traditional GraphQL servers, like we saw before. And that opens some interesting doors. Perhaps something like reviews that I talked about earlier is a good fit for a native database implementation, taking advantage of built-in searching or aggregation capabilities. Or consider building a new application when you already have a data graph. Often, applications have just a little bit of data that's specific to that one app. With a Federation-aware database expanding the graph with, say, one or two extra types and a couple fields, you might end up running in no time at all. So we're super excited to work with anyone to help implement Apollo Federation. And we're also happy to help teams with graphs make the transition. For those of you thinking about expansion, we have 2 talks today that I encourage you to attend. First, Jim Gust and Dan Berner from Expedia will share how they built out their Expedia graph and how they use stitching and now Federation to manage its expansion across the org. Later, Jeff Hampton from Apollo will offer a hands-on look at the core concepts behind Federation and how you can use them to implement modular schemas. The third development I want to look at is on the consumption side, the modern client stack that's emerged. For the lion's share of teams, this is where you first encounter GraphQL and its amazing benefits. And quite a bit has changed over the last year that you can take advantage of. I want to focus on React here. Apollo has grown up alongside React. And for most app developers, it's those 2 technologies that make the core of your client architecture. And the idea is pretty compelling, right? React handles the UI, Apollo handles the data. They're both declarative technologies. You express intent instead of writing a bunch of boilerplate. We used to write code to manage the DOM, but no more. And same for Apollo in managing your data. The combination has matured in the last year. A couple things have happened. Number 1 is hooks. Apollo's gone through a series of interfaces to React, from HOCs to query components and now hooks. And hooks gives us by far the cleanest and most satisfying API for integrating the 2. It allows a really natural and pleasing way to staple a query to a component representing its data requirements in a concise and composable way. Hooks support recently got added to Apollo Client, and we strongly encourage you to adopt this pattern in your applications. The other development, of course, is TypeScript. We've found it exceptionally valuable at Apollo, as many others have as well. Modern React plus Apollo plus TypeScript gives you strong end-to-end typing across the entire stack, from your database all the way through your UI. And that combination, with all the parts working together, is really transformative for app development. Here's one example. In Apollo, when you write a query, like this one on the left for the user's information, it automatically generates a TypeScript interface for that query, pulling in the schema from the registry to get the types and the doc strings. So now your editor and your compiler have your back as you write client code. So in this case, it makes sure that you never forget to check for a null display name before using it. And it protects you if the schema changes later on to a now nulls in a field you've been using. These are the kind of bugs that you lose days trying to hunt down, and they just go away with these modern tools. Another example, Apollo Client isn't just for remote data. There's an elegant model where you can compose schemas on the client, much like we saw with Federation, to represent local state as well. We brought that idea into Apollo Client Core in 2.6, and again, I recommend adopting it. And the cool thing here is the tools know this schema. So autocomplete, linting, TypeScript interfaces, all that stuff reflects the compose schema that's specific to your client and that captures all the data in your app. Strong end-to-end types for all your data, including local state, all implemented in a simple declarative code based on a common API. And the best news is this is all approachable. You don't have to rewrite your client or have a huge flag day to take advantage of it. Right after this talk, Bree Bunge is going to show you how Airbnb is incrementally adopting these ideas, going to TypeScript, connecting Redux to the graph, moving components over to local state, and so on. Airbnb, I think, is a great proof point for the value of this modern stack. They've pushed this technology as far as anyone. And in my mind, there's nobody that values world-class user experience and development velocity more than they do. They've been a great partner of ours. So what does Apollo Client really do for them? And what do they get out of it exactly? To talk about that, let me zoom out for a second. What is the client, really? The heart of Apollo Client is its cache, which holds all your application data And there's APIs and plugins that connect that cache to your components, your local state, the network, and so on. It's the cache that makes the client really valuable. It acts like an air traffic controller for all of your app data. And it's especially useful for the kind of complex UIs that modern clients have. It lets you compose components in any combination on the screen, making sure all the parts of your screen are always consistent with the data that they show. It avoids unnecessary fetches over the network so users can have a smooth, fast experience as they navigate between different parts of the application. All that stuff is hard to test, hard to debug code you used to have to write by hand to have that really delicious app experience for every piece of the app. But as you roll this out across large apps, of course you run into limits. And working with Airbnb and others, we found cases where you had to think too much about how Apollo was doing its job and not enough on what you wanted your app to do. Consider search. This is an interesting case to me, where that cache machinery maybe isn't as helpful out of the box. Typically with search, we're fetching just a little bit of data, a few fields, about a lot of objects. That data is not likely to change over time. I've never seen a search interface that changes data underneath you. And it doesn't need to be kept in sync with other parts of the UI. And once the user navigates away from search, we don't really need to keep it around. The whole point of search is to get people where they are going. So the cost of normalizing all these small objects and storing them in the cache doesn't really pencil out here. And that's a good example of the kind of pattern we've wanted to improve in Apollo. For your app to be good, search has to be good too. And we want Apollo to help with that, letting the client do the work for you so you can focus on the important stuff. So I'm really excited to announce the first beta release this week of Apollo Client 3. It's all about better management of how you keep data around, built on a new implementation of the core cache that consolidates these sort of use cases into a unified programming model. It has built-in patterns for things like pagination that come up over and over again, but also comes with the fine-grained controls you need to manage these edge cases, like search. Many here will be happy to hear, for example, that Apollo Client 3 now gives you control over data eviction and garbage collection in the cache. And lest you think that this comes at a high cost, it doesn't. We were able to do this with a smaller and faster client, optimizing as we brought these ideas into core and structuring Apollo to let you import just the parts you need. So as I mentioned, stick around for Bree at Airbnb. And for those interested in the details of what's new in Apollo Client 3 and how you can make the transition, later today, Ben Newman, lead architect for Apollo Client, will do a deep dive into the new cache and the patterns that that enables. So let me summarize. GraphQL is mature and approachable. And here's some key ideas for success. Build a data graph, treat it like a product from the beginning. Start small, adopt an incremental approach, but think big. It's going to grow. Figure out who the graph champion is going to be. If that's you, think about how you can leverage your graph skills across your whole team and how you're going to measure the health and success of your work. Take advantage of the tools and technologies. That's where a lot of the value is. And you're going to see a ton of examples today and tomorrow. So find the ones that make sense for you and bring them back to your team. And follow the principles and best practices that we've found work best for data graphs. Learn from your colleagues, learn from your conference attendees. Share what's worked for you. These things will serve you well. No matter where you are in your journey, there's a clear, approachable next step, a path forward, and we're here to help. It's why we put on the conference. It's what's behind our commitment to open source, our Graph Manager tools, and our commercial services to help teams at every stage. So here at the conference, we've put together a roadmap to the data graph series of talks full of concrete, practical guidance for each step of the journey. For teams just getting started, the main thing is getting your data into a graph and seeing that end-to-end developer experience for the first time that allows. And later this morning, Danielle Mann will show you exactly what that looks like. If you're putting features into production, Michael Watson, a solution architect at Apollo, will present do's and don'ts for your schema, covering topics like how to make sure you have a demand-oriented graph that matches the needs of the client. Tomorrow, for teams looking to adopt and accelerate their agile graph development, Evans Hauser, an engineer on our Graph Manager team, will show you how to implement field rollover and some of the other techniques that are made possible with the data graph. And finally, for teams running a stitching gateway, or if you're interested in Federation, Adam Zions, lead of our infrastructure team at Apollo, will walk through how we incrementally transitioned our own API to Federation, with concrete guidance along the way for you. We started this Apollo effort because we saw the potential of GraphQL. We're dedicated to the vision that every developer should have a graph. You know, the Apollo name has a special meaning for me. 50 years ago, we sent this thing to the moon. And I think for many of us who practice the engineering craft, Apollo represents the finest sort of effort. Brilliant technical design, phenomenal execution, zero scope creep, a relentless focus on the key objective. But most of all, it was a staggering accomplishment that brought us all together, brought out the best in us, and changed the world forever. And that's how I think about this community. GraphQL is not some small thing. It's a rare opportunity, I think, to improve in a fundamental way how we write software, create new experiences, and welcome more people to our trade. And as I think about the years to come, it seems to me that we're all going to look back on this moment as a really special time, when all of us who saw it a bit early made a big bet together on something important and promising. So let's not forget that. Learn and share as much as you can at this conference. Please come talk to me. I'm really eager to learn from you. But let's also not forget just to take a moment to appreciate what we've done and who we've done it with and how far we'll all go working together. Thank you. Enjoy the conference.